Hello everyone! In the previous episodes we developed test stations and the database tool using LabVIEW IDE. Now we are ready to apply our knowledge to build a more comprehensive tool. In this tool we will bring together not only our programming knowledge related to data acquisition, data storage and data utilization using database tools, but we will also need a general understanding of production processes. This may apply not only to manufacturing something, but also to servicing and managing various operational processes. So, what is the field of knowledge we are about to enter? In general, it is known by the abbreviation MES, Manufacturing Execution System Software. This is the highest level system used to organize business structures that include many sublevels, such as inventory management and warehousing, accounting, human resources, logistics and transportation, customs operations, licensing, as well as participation in various parallel projects within the organization. The system we are about to examine does not have a standard implementation and is always strictly individual, depending on the enterprise where it is deployed and, of course, on the qualifications of the company providing the system. To propose such a system to a company, it is necessary to thoroughly understand all the details of the company's operations. Therefore, a very high level of trust is required toward the system provider, because the company will inevitably have to share its internal secrets as well as trust the provider with data protection, system security, and overall reliability. So, where do we start? To understand this large topic, let's look at what kinds of solutions are currently available on the market. Right now, I'm in Silicon Valley, in the Bay Area, which is the region around San Francisco. On the map, you can see San Francisco, and this whole area around it is the Bay Area. The capital of the Silicon Valley, Bay Area, is generally considered to be the city of San Jose. I live right between San Jose and San Francisco, in the city of Sunnyvale, so the results I get in Google search may differ from what you see. Moreover, just across the road from my house are Google servers. Many of Google's servers are located here in Sunnyvale, so the results Google shows me are probably influenced by local offerings. By the way, it would be interesting to know what search results Google shows you in your location. If you would like to share, write it in the comments. And when you make Google searches, those requests are processed right here at Google Sunnyvale. So I enter a search query using the keywords Manufacturing Execution System Software. Let me say here that MES software is mostly used to connect, monitor and control complex manufacturing systems and production processes. And the purpose of any production process is manufacturing goods and services, organizing and adapting those processes, and managing many related operations, such as logistics, certification, and also an essential part of any process, the transfer of state and responsibility. What does this mean in practice? It means the system must include a very wide range of functions, such as management tools, execution scheduling, and user interfaces for each operator at every workstation, since the tasks and operations at each position are unique. The system must also support integration with the required peripheral equipment at every stage of production or service, including the engineering test stations we discussed earlier. In addition, it should include an internal document workflow system where every step is verified with the signature of the responsible person, as well as an internal messenger for fast information exchange. Furthermore, the program must have a system of global variables and informational tags, its own server to manage them, a data storage system for archiving, and of course our favorite database. So let's try Google search and see what it suggests. Again, this is what appears for me. Your results may be different. Of course, the first results are sponsored links, companies that paid for advertising. We'll skip the sponsors The next link I see is a list of the best MES software systems according to Google. I'll take the names of the top 3 companies and enter them into ChatGPT, asking it to estimate the pricing offered by these companies. I simply copy the company names and ask ChatGPT to compare their prices. And here we can see that ChatGPT returns a price range starting at about $3,000 per month per production line. We can assume that one line probably starts with about 3 operators. Accordingly, if a company has several lines and multiple operators on each line, the cost will increase progressively. So, why did we do this analysis? If you're watching this channel, it likely means you're interested not only in how to apply your knowledge, but also in how to monetize it. So, we can see that the field we're entering is quite interesting. And since we already know what test stations are and how to integrate them, we also know how to connect peripheral devices and collect data in real time, how to store this data in a database, and how to work with big data. What remains for us is to understand the characteristics of the process, analyze it, create an algorithm and flowchart, define the execution logic, and then build the program. When developing such a program, we also need to consider many details: the design, various features such as pop-up windows, or perhaps a more conservative interface style. Determine whether it will be a local server solution or a cloud-based application, and coordinate all of this with the client. The client may also request the inclusion of artificial intelligence elements, voice commands, and other features. We discussed in previous episodes how this can be implemented with our program. If the application is web-based and will run in a browser, we will need to use the capabilities of our IDE, Integrated Development Environment, and include tools such as GWeb development software and web server. We will cover this in the upcoming episodes and see how we can create applications that run directly in a browser. But we'll talk about that a bit later. For now, let's return to the beginning. So, to begin developing an MES, Manufacturing Execution System software, we first need to choose a process that we will describe in our concept. Let's approach this from a practical point of view. We should determine which companies or enterprises we could approach with our proposal that might actually need such a system. Here you need to use some imagination as well as any connections or contacts you may have to gather preliminary information about the process and create an initial project. The company manager or the person responsible for the production process will likely be surprised and pleased if you manage to correctly identify the points that should be automated. And if your proposal clearly and simply explains how these complex operations will be automated, what economic effect this will produce, and ultimately how it will affect the cost of the product, it will be very compelling. Of course, what I'm describing right now is only a very rough, high-level overview. Every project is unique, and here an important question arises. Is it possible to create a system that is more or less universal, one that can be expanded and adapted depending on the needs of different processes? You might say that after everything I just described, such a thing would be impossible. But today I will try to prove that it is possible, and I will show you a fairly universal system that you can download to your computer today and see for yourself. So, where do we start? We start with gathering information. Of course, if you have insider information, things become much easier. For example, I have insider knowledge about the manufacturing cycle of micro LED displays. This is what such a display looks like when it's operating. Here you see a demo image of some castle with bubbles floating around, but this is not an OLED display with liquid crystals. It's a micro LED display, something you probably haven't seen before, because the technology is still not fully finalized and therefore not widely available. The display itself fits on the tip of a finger. What you see here is simply an enlarged version. Let's say I know that On the production line, one of the stations, or rather the process performed at that station, takes the longest time, which slows down the entire manufacturing process. One obvious solution would be to multiply the number of stations, turn one station into 2 or 3, but this would also require 2 or 3 operators, and from an economic standpoint, this is not efficient. From what I know, the largest portion of time is spent on the operators reporting and data entry into the database, filling out specification sheets for each product unit. So, the logical step is to optimize this process and automate some of these functions. How should my proposal look? Let's take a look. Here I have an example of such a proposal. Of course, I removed all real names and participants, leaving only the data. The goal of this proposal is to convince the company's management that the program I am proposing will be economically effective. Here we see a station where one of the technological processes on the production line takes place, specifically the LED transfer process. In other words, the grown crystals are transferred from the substrate to the backplane, and after the transfer, we obtain a set of parameters that must be entered into the database. On the second page, we see a diagram of the production line automation cycle, which includes our station called LS4 along with the operator's user interface. Next, we describe the process of how the collected data will be sent into the central database system and stored in the appropriate tables. Then we see the user interface, meaning the tabs that participate in the data collection process. For example, from the leftmost tab, we collect information about the operator, code ID, part description, notice, and comments. From the second tab, we collect pressure data. From the third tab, we collect positioning information. From the fourth tab, we collect configuration settings. From the fifth tab, we collect main parameters. All of this information is then aggregated in tab number 6. After that, we propose a next generation transfer tool, but that is not related to today's topic. For now, we'll stop at this point. Now let's look at how the process appears in real life. In this case, we see an experimental station where our program is being used. This is exactly the process we intend to automate. You're probably curious about what is happening here. I'll briefly explain. What you see is the alignment of a laser beam, which is used to burn through a germanium substrate. The goal is to optimize the intensity of the Gaussian beam in order to create the smallest possible blemish, spot. In this case, we know that the size of a micro-LED is 10 by 10 microns, which means the laser spot should be about 5 microns in diameter. The spots you see here are approximately 5 microns across. For comparison, a human hair is about 80 microns in diameter. You can also see the equipment working with our software. These are National Instruments tools, including a PXI real-time controller and a digitizer, which is a digital converter. In this setup, the system achieves a transfer speed of about 90,000 laser shots per minute. That means within 1 minute we can fully place one color of the RGB set. In other words, using the laser, we attach the micro-LEDs onto the substrate known as the backplane. Of course, after this station, there are additional processes. For example, to separate the sapphire substrate, where the LED crystals are grown, from the functional backplane, we use the LLO method, laser lift off. But these are technical details, and for our current discussion, they are not important. In this case, what interests us is the report that must be generated automatically immediately after the transfer operation is completed. Here we can see that once the transfer operation finishes, a report is automatically sent to our system. How can we verify this? We simply open our system, enter the operation cycle that we just performed, and we can see the visual record of the action that was just completed. This means that the operator did not need to manually enter any information. Everything was done automatically in the background. This not only saves working time and maintains the pace of production, but it also eliminates the possibility of human error. At the same time, it allows the operator to stay focused on the primary task, properly performing the loading, alignment, and monitoring of the process. So now we have seen our MES system, manufacturing execution system, in action. Next, we will install this program on our computer. You will also be able to download it. I will leave the link in the description, and install it on your own computer to try it yourself. You will receive a zip file which you should extract somewhere on your computer. Inside you will see a folder containing setup.exe. I will launch it now. You can see that the installer shows verified publisher. Of course, I accept the license terms. Now we see that a desktop icon has appeared, which means the installation has been completed successfully. I click the icon, and we can see that our program has been successfully installed and is ready to use. Next time we will start learning how to work with this program. And that's all I've got for today. Thank you for joining LaPlanta Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to learn more from upcoming episodes.